So good day, grade 8 Mahati Science High School students, and to our viewers on YouTube. Okay, so this are going to be our seventh lesson in geometry for the third quarter. Okay, we have special right triangles. This is also our 23rd lesson for the entire course in geometry. Okay, so I know you guys have a lot of background knowledge already and special right triangles since we've been using them since the first quarter. Okay, so let's try to do more problems just involving special right triangles for this lesson. Okay, so let's start with this problem. Okay, so Greg and Philip were trying to create a new Scrabble game they called Trium. And instead of square tiles, they used triangular tiles to fit the letters and form lexical terms. They wanted to find the perimeter of the Trium board game that they created, given that the measurements of the triangular board below, okay, so given the angle measurements here, and that the only side measurement that's given is this height of the triangle trium ABC. So that's square root of 3 decimeters. So how can we guys solve for the area of this board game? To get the area of the board game, okay, area of the board game or area of triangle ABC, first we have to find the area of triangle ABD, and then we have to add the area of triangle BDC to that. Okay, to get the total area of the entire triangle, logically speaking. Okay, so first we need to find the measurement of the bases. Okay, the bases of these triangles. Okay, for the first one, we have here this triangle ABD. Let's try to examine triangle ABD here. So we have here square root of 3, and its opposite angle is 30 degrees. So therefore, if this is 90 degrees, so this must be 2s. So, okay, 2s. So therefore, the side measurement opposite to this one, this is the 60-degree angle. So therefore, the side measurement to that one is going to be s square root of 3. And since s, for this problem, s is equal to square root of 3, so therefore this is going to be square root of 3 times square root of 3 for the side measurement or the base, okay, for the base for AD. And what's square root of 3 times square root of 3? So that's just going to give us 3. So therefore the measurement of side AD or the base is equal to 3 for this one. And since we now have the measurement of the legs of the special right triangle that we have here, we can now solve for the measurement of AB. Okay, but do you think that we have to find the measurement of AB for this one, since we only want the measurement, since we only want the measurement of the area, okay, for this one, to get the total area, okay, we will not need the hypotenuse. But let's try to examine again the problem, guys. It's asking for the perimeter. Okay, so if it's asking for the perimeter, and also let's solve for the area for the problem, is also solve for the area of ABC, and of course also the perimeter. If we're going to solve for the perimeter, then we're going to need the measurement of AB, the hypotenuse for this one. So we're going to solve two problems. We have two objectives for this problem. First is the perimeter of triangle ABC, and second is the area of triangle ABC for this one. Okay, so to solve for the perimeter, or to solve for the line segment AB, that's gonna be AD squared plus BD squared is equal to AB squared. And since we know the value of AD, it's equal to 3, and we know the value of BD, it's been given here, that's square root of 3. So we can solve for the value of the hypotenuse. So therefore, this is going to give us 9 plus 3 is equal to AB squared. And that's going to give us 12 is equal to AB squared. And if we take the square root of both sides, what's the square root of 12? That's 2 square root of 3. So therefore, the measurement of this side is equal to 2 square root of 3 of side AB. And this is going to be useful later when we try to solve for the perimeter of this triangle. Okay, so we have here again this triangle, and then we also need to find the measurement of this side as well. We need to find the measurement of that side. Okay, so using our logic here, let's try to draw, okay, the right triangle again. So we have here 60 degrees, and we have here the opposite of 60 is square root of 3. Okay, so for this one, if the opposite side of 60, okay, the angle, the side measurement opposite to 60 degrees is equal to s square root of 3, and we know that the value of the side is equal to square root of 3. So therefore, we can solve for the side measurement of the second right triangle that we have here. So if square root of 3 is equal to s square root of 3, we can divide both sides by square root of 3. So therefore, we know that the side measurement for triangle BDC on side measurement DC is gonna be square root of 3 all over square root of 3, and that's just gonna be 1. So there you go. So therefore, for this problem, okay, DC is just equal to 1. Segment DC is just equal to 1 if the height is equal to square root of 3. And of course, the side measurement here is just gonna be 2 times 1, which is equal to 2. And there you go. Now we can solve for the perimeter of this triangle. So the perimeter is equal to AB plus BC plus AC. And since we know AB measures 2 square root of 3, and BC measures 2, and AC measures 3 plus 1, okay, which is equal to 4. Okay, so that's gonna give us 2 square root of 3 plus 2 plus 3, which is 5, and that's gonna give us 2 plus 3 plus 1, which is equal to 6. So therefore, we have solved the perimeter of this triangle. The perimeter of triangle ABC is just equal to 6 plus 2 square root of 3 decimeters. Or if we try to convert that into decimal, so that's going to be 9.46. So that's around 9.46 decimeters if we try to approximate the value of the perimeter. 9.46 decimeters for this one. Okay, so let's just try to check out. If we have 2 square root of 3 here and we have here 2, let's try to check for the measurement of the hypotenuse. Okay, so that's going to be a squared plus b squared is equal to c squared. And that should give us 2 squared plus 2 square root of 3 squared should give us c squared for this one. And what's 2 squared? So that's going to give us 4 plus, okay, so it's 2 square root of 3 squared, so that should give us 12. And what's 12 plus 4? So that's going to give us 16, and ergo, there you go. Okay, so therefore the hypotenuse is indeed equal to 4. Okay, so we can solve for the hypotenuse in 2 ways. We can solve it using the Pythagorean theorem, or we can find it using the by adding the 2 side measurements that we have here, 3 plus 1. Okay, and then also we can solve for the area. Now that we know the perimeter is equal to 9.46 decimeters, we can now solve for the area for this one. So the area is gonna be 1/2 base times height plus 1/2 base times height. Since we know that the base of the first, okay, or actually for this one, since we know the base is just equal to 4, and we know that the height is equal to square root of 3, we can now solve for the area of the entire triangle. We don't need to find the area of these 2 triangles. We just need one triangle, the area of the entire triangle itself, because since we know the base already, AC is equal to 4, and we know that the height that's given is equal to square root of 3, we can say that the total area is equal to 2 square root of 3 squared decimeters. Okay, and if we try to round that off, so that's gonna give us, okay, that should give us 3.46. Okay, so the area of this figure is equal to 3.46 squared decimeters. And that's how we solved it for this problem.